Merge sort. Merge sort is a classic example of divide and conquer algorithm, and in this particular case we are using divide and conquer technique in order to sort an array. The basic idea behind merge sort is to break down a problem that is a larger problem into smaller manageable subproblems and then combine the solutions of these manageable subproblems in order to find final solution for the larger problem. So it is not just for the merge sort. For any of the divide and conquer algorithms, we'll use the same technique. That is, whenever you see a problem which is a larger problem, a complex problem, what will you do? You know it is difficult to solve as such. So you will divide it into smaller problems. Once it is divided, you know these smaller problems are manageable. You can solve these. So you will separately solve all these smaller subproblems, and once you are done with all the solutions, what will you do? You'll combine all the solutions together. When you combine the solutions of smaller problems, you'll get solution for the larger problems. So this type of technique is useful only when you have a problem in which you can combine the smaller solutions so as to find solution for the larger problem. And merge sort is one such scenario. So let us understand how exactly it works in sorting. So I told you there is a divide phase and a conquer phase because it is divide and conquer algorithm. Let us understand what exactly happens in divide phase and what exactly happens in conquer phase of merge sort. We'll go to the divide phase first. What happens in divide phase? You have an input array. How can you divide this? You'll divide it right in the middle. As soon as you divide, you have two arrays which are half of the size of the present array. What will you do next? You'll again divide each of those into two arrays. So now you have four arrays. Each of those are 1/4 the part of actual array. You'll keep dividing again and again till you find arrays of size 1. This is the divide phase. So in your divide phase, you are going to divide the array into half and so on till the point you are left with only one element. This is the divide phase. And what do you do in the conquer phase? In the conquer phase, you are going to do the opposite. From the one element point, you are going to conquer back to reach full array. How do you do this? What is your aim first of all? Your aim is to sort. And you know, when you have only one element, that is by default sorted, because there is only one element, it is sorted by default. So what will you do now? When you have only one element, think of the last level which has only one element each. You will combine two such arrays which are having only one element. And when you're combining this, it's easier to sort because you know you just have to compare one element each, and in this level you will have all the arrays having two elements each. What is the next step? You will combine two such arrays which are having two elements each, but the advantage you get here is both these arrays are already sorted. So it's easier to combine. Why is it easier to combine? When you're combining, you can use a simple technique. You start from the leftmost side of this array and the leftmost side of this array. In both the arrays, keep a pointer at the leftmost side. Then what you do is you compare and see whether the leftmost element of this array is smaller or this array is smaller. Whichever is smaller, pick that element into the final array's first position. So let us say from the left array, this array, you picked one element because this was the smaller element. So once you are done with it, you will move to second element in the first array, and in the second array you will still stay with the first element because you are still not done with that. Again, you will check whether this element is smaller or this element is smaller. Whichever is smaller, you will place it here. So when you continue this, you simply by comparing two elements at every point, you can combine and form the larger array. Again, at this stage, you will have all arrays of size 4. You will again combine two elements, two arrays each of size 4. Similarly, you keep doing this. Finally, you will reach a position where you have this complete array sorted. Let us understand with this with an example. We'll use numbers because that will make it much easier to understand. So let us start with the array we used in previous lectures, because I want you to connect how differently this algorithm is working on the same numbers when you compare with whatever algorithms we learned earlier. So let us take this array. This is my initial array. It has 42, 70, 12, 30 and 24. These are the elements that I have in the initial array. 5 elements are there and I want to sort this array. What do I do first? I want to find the middle point. So this is my middle point where I'm going to break the array, divide the array. What do I have now? I have two arrays. One is having 42, 70 and 12. And the second one is having two elements, 30 and 24. What do I do next? I again divide this into 2. So I'll divide here. I have two different arrays here. One is having 42 and 70. Other one is having only one element, which is 12. What about this side? I'll again divide this into 2 here. One is having only 30 and the other one is having only 24. This one is still remaining, so I'll again divide it here. One is having only 42, second one will have only 70. So at this point, I have a lot of arrays which are having only one element, but all the arrays are having only one element. This is having only one element 42. This array is having only one element 70. Okay, I'll draw squares so that you are clear it is an array. This array is having only one element 12. This is having only one element 30 and this is having only one element 24. The same way I divided, in the same order, I'm going to combine back and see how I can create a sorted array. How will I combine these two, 42 and 70? I'll simply see whichever is smaller. 42 is smaller than 70. So at this point, consider this is free. I'll see 42 and 70. Whichever is smaller, I'll fill it here. Then 70 is only remaining, so I'll fill 70 here. So I'm removing this off because it is irrelevant now. I'm presently having this array which is 42 and 70 and you can see it is sorted. This is already sorted because only one element is there. This is already sorted because only one element is there. This is already sorted because only one element is there. Next step, I'm going to combine all these to the next level. In the next level means this level. So when I conquer at this level, what happens? I'll have one pointer at first element of this array, one pointer at first element of this array, and I'm going to combine here. When I try to combine, whichever is smaller, 42 or 12, which is smaller? 12. So I'll write 12 first. After this array is completed, so I can simply write whatever elements are there in this array in order because this array is already sorted. So 12, 42, 70. This is this array. So this array is already sorted now. So I'll remove these off because these are irrelevant now. What about this array? I have 30 and 24. Which is smaller? 24 is smaller and 30 is larger. So 30 comes on the right side. At this point, I have this array sorted as well. So here I have a sorted array 12, 42, 70. Here I have a sorted array 24 and 30. I'm going to combine this back at this level so as to get final sorted array. How will I get this sorted array here? I will have a pointer here and I'll combine and see whether 12 is smaller or 24 is smaller. Which is smaller? 12. So I'll write 12 here. I'll write 12 here and update this pointer to next element. Which is smaller now? 24 or 42? 24 is smaller. So I'll write 24 and update this pointer to next element. Which is smaller now? 42 or 30? 30 is smaller. So I'll write 30 here. And this array I'm done. So I'm removing this off. Whenever I'm done with one side of the array, then whatever elements are remaining in the other array, I can simply write it as it is because it is sorted. So I'll write 42, 70. So at this is how I generate a sorted array using merge sort. So now it is a sorted array. This is the algorithm that is used in merge sort. I hope it's clear for you how we did divide step And then we did conquer step. So divide, we did from top to bottom. We were dividing the array into smaller elements till we get element of one size. Then we conquered by coming back. We combined the elements at each step so that finally we reach back to the complete array. This is how we sorted using merge sort. What we will do now is we'll write the pseudocode. After writing the pseudocode, we'll try to understand how the time complexity and space complexity works in this case. So pseudocode, while writing pseudocode, this is slightly complex when compared to the previous sorting algorithms that we had learned. It is slightly complex because there are two parts. One is divide and the other part is conquer. So in the merge sort algorithm, you should first write the code which will divide it into two halves, and after that you should write the code which will combine it back, right? So this is what we are going to write. As we go on with the pseudocode, we'll understand how to write, okay? So merge sort algorithm, we'll write pseudocode here, merge sort. I want to sort an array A and I'll define two variables, left and right. So left and right, they show the leftmost and rightmost indices of my array. So if this is my array, the leftmost index, this is L, rightmost index, this is R, okay? A is my array. This is my array A. So what will I do here? First thing is, I'm going to do the divide state here. So when I'm dividing, I want to divide till the point there is only one element. So when there is only one element, what will happen? Left will be equal to right when there is only one element. Till this point, I have to keep dividing. So I should keep dividing till the point if L less than R. So if left is less than R, till that point I have to keep doing this. That is why I am putting this condition. If left is less than R, what should I do? First I have to find the middle point. How will I identify mid? Midpoint can be identified as left plus right divided by 2. I'm putting 2 divided sign here so that so as to show it is integer division, okay? So if I get something like 3.5 or something, you should take it as 3. That is integer division. So mid is equal to left plus right by 2. So I have an array. I have a left index, right index, and I also identified whatever is the middle index. Let us say this index is middle. I identified mid. After this, what should I do? I have to divide it into two parts and then conquer them. So in order to divide, I'll write a recursive algorithm here, merge sort of array. On the left side, I'll still keep left index and right side should be mid index. So this is the first part of division. Second part, I'll call it as merge sort of array mid plus 1 right. So my first merge sort call, this is for the array from here to here. Second merge sort call is for mid plus 1 to R, the remaining part, okay? So at this point, what I've done is, this is plus 1, okay. So at this point, what I've done, I've divided into two parts. After I have divided, I have to merge them. That is, I have to do the conquer step, which is merging these two parts. At this point, I only have two different parts and the next step is to merge these two. So for that, I'll now write an algorithm called merge. So we'll write this algorithm separately after this. Otherwise, it will be very long here. A, left, mid, and right. So this is the merge sort algorithm. I'm going to explain this merge algorithm. Just wait. So in merge sort algorithm, what we have to do is, first you have to find the mid element. Then one part is from the left till the mid. Second part is from mid plus 1 to right. And once you are done with both these, what do you have to do? You have to merge both these parts. So this is a recursive algorithm which says you do merge sort for the first part of array, come back. You do for merge sort for the second part of array, come back. Once that is done, what will I do? I'll merge both the parts that are available. Let us see what is the merge algorithm, how to write merge algorithm. So in merge algorithm, what should we do? We should consider that we already have both these arrays. That is, we already have the array, both the half arrays which are sorted. So considering that we have both sorted arrays, because from this step we'll already have sorted arrays. Given that you have the sorted arrays with you, how can you merge them? That is the merge algorithm. So the next step for us is to write merge algorithm. Merge. Merge of array left, then you have mid. I'll write M for mid and R for right. So this is okay. You should not okay. M should be good for mid, right? Okay, left, mid and right. So this is the algorithm I have to write now. So how do I write merge algorithm? I'm going to clarify merge algorithm here. So here I'm considering I have two arrays with me. First array has indices from left to mid. Second array has indices from mid plus 1 to right. My next aim is to merge both these arrays into a single array, right? So this is a single array only, but I am considering it as two parts. That is, I have a large array which have indices from L to R. But what am I doing? There is another index called M. I am considering this much as one array, this as another array, and then present task is to merge both these parts. Okay, so I'm going to merge this now. How do I merge? First thing, I have to create two different arrays and copy all these elements into those arrays. Why am I copying? Because when I copy the final array back, that copy has to be done to the original array. Whatever is the original array that I have, which is having index from L to R, and also there is an index M. This is the original array. To this I have to do copy, which means I should not manipulate any values which are inside this. In order to do manipulation, I should create two new arrays to which I should copy both the half arrays. And then when I'm merging, I should put final sorted values back into the main array. So for this reason, I'll create two separate arrays. So the first array, size of first array should be n1. I'll call it n1. What should be the size? I know till mid is the size, first array, the first half of the array. So I should do mid minus left plus 1. Why is it mid minus left plus 1? Because first index is L, last index is mid. So if you do simply mid minus L, you will be one short. You want total size. So that is mid minus L plus 1. So for example, if your low is 0 and mid is 5, if you do mid minus L, you will get only 5 minus 0 is equal to 5. But actually there are 6 elements here. 0, 1, 2, 3, 4, 5. There are 6 elements. That is why I am doing mid minus left plus 1. Next thing is size of second array. Second array. What is the size of second array? It is right minus mid. Why is it right minus mid? Because left, mid and right, these are the positions. But my second array is only starting from mid plus 1, which means doing right minus mid will give me this size. So I want to create two new arrays now. That is the next thing. I will create two new arrays. First thing I'll call as left array. So in this left array, I'll call it LA, left array. It will be from 1 to n1. This is the size of left array. What about right array? I'll have a right array. Right array is from 1 to n2. So this is of size n1. This is of size n2. Okay. I've created two half arrays. Into this, I have to copy whatever is there in the previous sorted half arrays. So how will I do that? For I is equal to 1 to n1. I'm going to fill this left array. Okay. So I equal to 1 to n1. Left array of I is equal to, what should it be? From the main array, I should take the index left plus I minus 1. Why is it left plus I minus 1? Because I is from 1 to n1 here, but my actual array A that is having indices from 0. So in order to counter that, I gave a -1 here. Okay. What next? I have to do the same kind of copy to the right array, so that my left half array and right half array, they are copied to two separate arrays. So my second half array is for j is equal to 1 to n2, my right array of j is equal to a of mid. A is the major array, a of mid plus j. This is what I want to do. So at this point, I have copied the left half array and right half array into two separate arrays. So this is my full array. From this, I have copied left half array and right half array separately to two different arrays. And what are the specialities of both these? Both these are already sorted because I already did that procedure before. Like, I'm assuming that it is done before because we already reached merge step. The next thing is I have to merge both these into larger array. What is the step? I have to keep a pointer at the beginning, and then I have to keep comparing whichever is the smaller element. Whichever is smaller, I'll simply copy it to the larger array. That is the logic. So how will I do that? Okay. So for doing this, I'll need a while loop. Before while loop, what do I need? I need to initialize whatever variables I want. So let us say I want I is equal to 1, j is equal to 1. So this I and j are for keeping track of left array and right array. And then I'll have k is equal to left. So this is for keeping track of the main array. So these three pointers, I, j and k, they will keep track of left array, right array and main array. So the next thing is, to the main array, I have to copy everything in sorted order, given that the left array and right array are already sorted. Okay. So I'm going to write the loop for that. While, what are the conditions? My I and j, they should be within the limits. So I should be less than or equal to n1, which is the size of left array, and j should be less than or equal to n2, because n2 is the size of my right half array. Okay. So inside this loop, what should I do? I'll check whether the element of left array is smaller or right array is smaller. Whichever is smaller, I have to keep it in the main array. So if left array of I is less than or equal to right array of I, what should I do in this case? Right array of j. In case it is if left array's element is lesser than right array's element, what should I do? I should copy the element in left array to the main array. So what will I do? My main array is a of k. So k is keeping track of my main array. A of k is equal to left array of I. And after this, I have to increment the pointer in left array. So I is equal to I plus 1. And what about the else case? That is, if left array is not less than or equal to right array, that means the element that is pointed in the right array is larger. That is by default. So in else case, what should I have? I should have a of k is equal to right array of j. And then what should I do? I should do j is equal to j plus 1 instead of I equal to I plus 1, because j is already used, right array element is used. I have to go to the next element. Once I am done with this, there is something an incrementation is to be done, which is common to both these. What is that incrementation? That is the increment of main array, k equal to k plus 1, because I have already inserted at this point, I have inserted the element in main array. I have to do k equal to k plus 1. So what happened here? I checked whether the left half array has smaller element pointed or whether the right half array has the smaller element pointed. Whichever be the smaller element, I put it into the main array and then incremented main array pointer as well as whichever pointer is applicable on either left or right array. Okay. So this is what is done at this point. What is remaining now? whenever it comes out of this while loop, what will be the scenario? Just think about it. Your condition is violated. Condition says both I and j should be within the limit. That is, I should not have crossed the limit of left half array and j should not have crossed the limit of right half array size. So whenever I come out of this loop, there can be three scenarios. One possibility is that it crossed the limit of left half array. Another possibility is that j crossed the limit of right half array. And the third possibility is that both are crossed. So assuming that either of these is crossed but not both, there may be a case that left half array or right half array, any of them, are having remaining elements. So I have to write extra while loops in order to handle that. So how will I write that? For that I need a while loop, while, what should be the condition? I less than or equal to n1. So in case my j is already completed but I is not, in that case I less than or equal to n1. What should I do here? If I is less than or equal to n1, what is to be done? I should increment only i's pointer and not k's pointer. So a of k will be equal to left array of I. And then what should I do? I should do I equal to I plus 1 and k equal to k plus 1, right? This is how I do it only for the left subarray. And what if the right subarray is remaining instead of the left subarray? In order to handle that, I'll write one more while loop. So what is this while loop going to do? While j less than or equal to n2, that is, in case the right subarray is having elements remaining, in that case what will I do? I'll do a of k is equal to right array of j, and then I have to do j equal to j plus 1 and k is equal to k plus 1. So this is the complete algorithm for merge sort. So we did merge sort algorithm and then we did merge algorithm. Let's just look at it once again. In the merge sort algorithm, what did we do? Initially, we wrote merge sort algorithm here, in which whenever left is less than or equal to r, that is whenever the array is larger than size 1, what did you do? You found out the middle element, divided it into 2, and for each of those, after you divide, at this point you are assuming that merge sort algorithm is done, because this is a recursive algorithm. Whatever this algorithm does, each of these recursive parts will also do the complete work. So this merge sort algorithm, this merge sort algorithm, it is supposed to give the final sorted array, right? So your merge sort sub array algorithms, this one and this one, they are supposed to come back with final sorted subarrays, that is left array which is sorted, right array which is sorted. So at this point you can call merge algorithm, which will merge both the left and right subarrays. And in the merge algorithm, what did we do? In the merge algorithm, we first defined new arrays. We created two new arrays which are of the size of left subarray and right subarray. So those were called left array and right array. What did we do with those? Initially, we copied the left subpart into whatever we newly created as left array and the right subpart into whatever we newly created as right array. After that, what did we do? Now that we have both the subparts in two separate arrays, we can afford to copy all the sorted elements onto main array. How will you copy? You will keep a pointer to left and right subarrays. Whichever is the smaller element, you have to copy it to main array. So how did you do that? You put a while loop in which you checked whether the element pointed in left array is smaller or right array is smaller. In case left array is smaller, you will copy element in left array onto the main array. And in case right array element is smaller, you will copy the element in right array onto the main array. After that, what will you do? After that, once you come out of this loop, you are considering that either of the array is depleted. So if the case is that left array is not depleted, then you will simply copy all the remaining elements of left array onto the main array. In case right array is the one which is not depleted, then you will simply copy everything on the right array onto main array. So this is the merge algorithm that we have written. The next thing is to identify what are the time and space complexities of this merge sort algorithm. How do we understand time and space complexities here? First thing, in order to understand the time complexity, there are two things you have to consider here. One part is dividing it and the other part is merging it. This merging part, it should always take order of n time, and this dividing part, it should take that much time as much as it takes to reach from larger array till array of one size. So how do we understand that? If we draw it like this, if this is your complete array, when you divide it into two, you have these two arrays. Again, when you divide further, you have even smaller arrays. Again, when you divide, you have even smaller arrays. This is the scenario. So how do you find how many steps are there to reach from this position, top position, to the smallest position? This is one question. That is, when you are calculating total time complexity, you have to calculate time taken or work done, both are the same, at each level into number of levels. So first thing you have to calculate is the time taken at each level, and second thing is number of levels. So when you see both of these, you will understand what is the total time taken. What is the time taken at each level? Each level, what are you doing? You are copying all elements to another array. That is what you are doing in each level, because you have a left array, you have a right array, and you are going to copy all these elements by comparing to each other into the main array. What are you doing in this level? The same process but in smaller arrays, but the total number of elements is the same, because be it in many smaller arrays or in one larger arrays, total number of elements you are manipulating is the same, and manipulation of each element takes only order of one time, which means at each level you have order of n work. So is this clear? That at each level of this you are having order of n work, because there are a total of n elements at each level, and you are doing order of one work to shift elements from here to here. So you are just doing one comparison and one shift in order to shift one element from one level to the next level. So order of n time is taken at each level. The next question is, how many levels are there? How do you understand how many levels are there? In this particular case, you are starting from top position. You are dividing it such that each time the total number of elements is divided by 2. That is, it will become half. Total number of elements will become half. If you go like this, what is the maximum number of levels possible? How do you find that? In order to find that, you need to see like this. At level 0, what are the total number of elements? N elements are there. What happens at level 1? That is, you divided this array into 2. What is the situation at this level 1? Each of these subparts, they have n by 2 elements each, right? And what about level 2? In level 2, each of these subparts, they will have n by 4 elements each. This is also right. As you go like this, at level k, what happens? Each of the subparts will have n by 2 power k elements. Did you understand why this is n by 2 power k? Because this is n by 2 power 0. That is what you call as n. This is n by 2 power 1 at level 1, which you call as n by 2. This is n by 2 power 2 at level 2, which you call as n by 4. Similarly, if you see, at level k, you will have n by 2 power k elements for each of the subarray. Then, what is your stopping condition? When are you going to stop this division? Whenever you have only one element, which means this n by 2 power k, whenever this becomes 1, you will stop this process. That many times you will go down the levels. Whenever your n by 2 power k, it is equal to 1, you will stop. This is what you're going to do. Because your ultimate aim is to create arrays which are having only one element. That is why you're dividing. So this is clear. Whenever n by 2 power k equal to 1, whenever you reach a kth level such that n by 2 power k equal to 1, that is when you are going to stop. So when n by 2 power k equal to 1, that means n is equal to 2 power k, which implies k is equal to log n to the base 2, right? So we understood that the value of k is log n to the base 2. And what is k? K is the total number of levels that you are having, which means maximum number of levels you will have is log n to the base 2, which means you have a total of log n levels. And at each level, you have to do a work of n. That means total time complexity is order of n into log n. That is order of n log n. So in case of merge sort, time complexity is order of n log n. What is the space complexity? You are using additional arrays. And what is the size of additional array? Exactly equal to your main array, because you are forming two sub arrays which are each half the size of main array, which means total space taken is order of n. So here you are taking order of n extra space. So time is order of n log n and space is order of n. And what does this mean? Space is order of n means this algorithm is taking additional space, additional array in order to run, which means it is not an in-place algorithm. It is an out-of-place sorting algorithm. And secondly, one more thing, whenever you are talking about sorting algorithms, you have to understand whether it is a stable algorithm or not. So merge sort is a stable algorithm. The reason is, whenever you have two elements of the same value, that is if two elements are of value 10, you are not going to change the order, because even if you consider it got divided here, when you are combining them back, the condition is left less than or equal to 5, right? Which means in our merge algorithm, if you see, the condition that we kept is left less than or equal to right. So when you're keeping this condition, what happens when you're keeping condition left less than or equal to right? In that case, if left is equal to right, then also left is given priority, which means whichever element remained in left side on the original array will remain on the left side itself in the final sorted array, which means this is a stable sorting algorithm. So it is stable and out of place.